Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence or the feedback from each one of you, the quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the comment box, and then we'll move it within the agenda of the today's class. And the agenda of the today's class is going to be, we are going to take the two numericals which are based on the concept of sensitivity. The theoretical part is already been over in the last class, so definitely let me write what would be my agenda. At very beginning, I would be taking few number of problems based on sensitivity, and once the two problems from the sensitivity is getting over, we'll move it to the next very important topic, and there we would be analyzing the stability of the system, and the tool which we would be using for the analyzing the stability of the system is nothing but the ROUTH HURWITZ. That means we would be discussing about the ROUTH HURWITZ. Yes. Anyways, if you guys would be able to recall what we have studied in the last class. Basically, I talked about the sensitivity. In sensitivity, we had the two variables. The first was independent variable and the second was dependent variable. And in case of sensitivity, we wanted to just calculate how sensitive the dependent variable with respect to the change of the independent variable. So anyways, if you guys would be able to recall what we have studied in the last class, so let me go into the digital board. Here we saw the sensitivity of the dependent variable A over B was written as the percentage change in A, which was dou A divided by of A. In percentage, definitely 100% is going to be multiplied, and similarly at denominator side we'll have dou B of B, which is a percentage change in B, and here again 100% would get multiplied. Agreed? And the 100% goes off, and here we get the result as B divided by of A, dou A divided by of dou B. Yes. Till this point we have studied in the last class, and even we calculated the sensitivity of the transfer function in case of closed loop system. If you guys would be able to recall what was the formula, so anyways the formula was the ST of G, or I can say the sensitivity of the closed loop transfer function because of the change in G, closed loop was simply equals to of 1 divided by of 1 plus GH, where the GH was nomenclated as the open loop transfer function. Even if we wanted to calculate the sensitivity of the transfer function with respect to the change in G in case of open loop system, it was simply found to be 1. Yes. Till this point nobody should have any doubt, because already this all calculation have been done in the last class. Now it's turn to take few number of problems. And one thing is quite sure, if you have gone through these questions conceptually, probably you would be able to appreciate the sensitivity into the better way, and not only that, even you would be able to smash all of the problems related to the sensitivity very easily. It is a very well designed problem. You can put it 3 star over this problem. It is a very well designed problem. Agree? Anyways, if we talk about the history of this question have come in GATE Electrical year of 2010, and the problem was designed by IIT Guwahati. So let me read the problem word by word, and we'll try to conceptualize what the problem exactly says. Yes, try to understand what the problem states. As shown in the figure, a negative feedback system has an amplifier of gain 100. You can see very well. If you talk about this complete system, definitely the output has been fed back to the input side, and here the polarity is negative. That means the type of feedback is going to be a negative feedback. Not only that, even the gain is clearly given as 100. You can see the forward gain is nothing but 100 with plus minus 10% tolerance. What does it mean of it? See, any of the system is not a perfect system. If you design resistance maybe with a worth of 1 kilo, definitely there would be a tolerance with the resistance, maybe 1 kilo plus minus 5%. That means the 5% the resistance can go up, or 5% it can come down. That is why what I am saying, rather giving the exact value of G, what has been given in your problem, G plus minus the percentage change in G. So may I know what's the G over there? The G is precisely 100, and what's the percentage change over the G, which has been clearly written as dou G divided by of G into of 100%. Nobody should have any doubt in it. It's the absolute value of G, and the 10% is nothing but the percentage change over the G. And how the percentage change in A has been written? It has been written as dou A divided by A into 100%. How the percentage change in B has been written? Dou B divided by B into 100%. So how the percentage change on G would be written? It would be simply dou G divided by G into 100%. Agreed? In the forward path and the attenuator, see, try to understand why this gain has been called as a attenuator. Keep in mind, whenever the gain is mod of A, whenever the gain is in between 0 to 1, neither 0 nor 1, or you can say lesser than 1. So definitely it cannot be called as an amplifier. Why? The amplifier is a device which amplifies the input signal, maybe in terms of voltage, current or power. But here the factor which would get multiplied with C and would go to the feedback side is 9 divided by 100. Definitely it's in between 0 to 1. So rather calling it transmittance or gain, habitually we call it attenuator. What does that mean by the attenuator? Anyways, attenuator is a device which have the factor of multiplication, although I won't be calling it gain. Why? Because the gain means something is getting gain. No, here we are not getting any gain at all. Yes, till this point each and everything must be clear to all of us. No. Forward path and the attenuator of 9 divided by 100. In the feedback path, the overall system gain is approximately. So I wanted to calculate the overall system gain. Anyways, if you guys would be able to solve this problem, I want the input over the live chat box. Tell me what's going to be the precise most answer for this particular problem. What would be the precise most answer for this particular question? Tell me which one is going to be the precise most answer for this particular question. So let me write down all of the important formulas which can be retrieved by watching this block diagram. First, what's the value of G? The precise worth of G is simply 100. And as far as this system is concerned, the percentage change in G, which is dou G divided by G into 100%, is precisely equals to 10%. Yes. The value of H is nothing but 9 divided by 100. Yes. May I know what exactly you want from this problem? See, the overall system gain is approximately. See. If G is supposed to change from its place, or the worth of G itself is changing, it has the worth plus minus 10%. So as the G is changing, definitely the T would also change. So the answer would not be a precise value of T. The answer would also come in terms of pure T, ideal T, and thereafter there would be a percentage change over the T. Agreed till this point? Yes. So nobody should have any sort of confusion how this percentage of 1%, 5%, 2% or 10% have come in the picture. Keep in mind, if G is supposed to change with a certain percent of G, so effect of the G would also go over the effect over the T. Could you understand what I am saying? So now the concept goes in this way. First you will calculate the perfect value of T, and secondly you would calculate the percentage change over the T. Here goes your perfect value of T and here comes your percentage change in T. So let me do that. So first let me calculate perfect value of T. What does that mean by the perfect value of T? Where there is no tolerance over the G at all. That means the G was fixed at 100. If the G is fixed at 100, what will happen? G is fixed at 100, what will happen? See, the T is simply going to be G divided by of 1 plus GH. G divided by of 1 plus GH. May I know what's the perfect worth of G? The perfect worth of G is nothing but 100. Obviously, sir? No doubt as such. And here goes 1 plus G. G is again 100. And what about the H? H is nothing but 9 divided by 100. See, deliberately the H has been chosen in such a way that the denominator would become a very simple. Yes, the 100 and 100 goes off. Here it becomes 1 plus 9, that's a 10. 100 divided by 10 simply becomes 10. What does that mean of it? That means when the G is fixed at 100, the net transfer function, the net gain offered by the system is simply equals to 10. But still there would be a certain tolerance. Why? Because G is not fixed at 100. It has the tolerance of 10%, and hence you would have tolerance over the transfer function also. So let me calculate that also. But how will you do that? See. Recall sensitivity of closed loop transfer function because of change in, here there is a change in G. Yes, sir. No doubt as such. So here it becomes dou T divided by of T into 100% divided by of dou G divided by of G into 100%. And you can see very well it is a standard closed loop system. If it is a standard closed loop system, negatively feedback, what would be the worth of it? We have already calculated in the last class. Nobody should have any doubt as such. Nobody means nobody should have any doubt as such. Yes. And anyways, we are focusing over the calculation of the dou T divided by T into 100%, whereas dou G divided by G into 100% is already known from the block diagram. And even the value of 1 plus GH is also known. So what I'll do, I'll just fix it towards the right hand side and I'll get the value of dou T divided by T into 100%. So let me do that. So here goes dou T divided by T into 100%. Here comes 1 divided by 1 plus the fixed value of G. May I know what it is? It's 100. It's 100, sir. Obviously, no issue as such. What about the H over here? The H is nothing but the 9 divided by 100. Here goes 1 divided by of 100 goes off, and here it would become 1 divided by of 10. 1 divided by of 10. Agreed? 1 divided by of 10. So here goes 1 divided by 10, that would be 0.1. 0.1. Yes. And may I know at denominator what it was? It was 10%. 10%. Yes. The dou G divided by G into of 100% was 10%. The 10% would go towards the right hand side. The 10% would get multiplied with a 0.1, and the percentage change with T because of change in G would simply be dou T divided by T into 100%. The 0.1 gets multiplied with a 10% and simply it would become 1%. 1%. That means, what did you notice out of this? See, the two outcomes we can brought out of it. The first one, if there is no change in G as such, or there is no change in G as such, the transfer function is simply 10. The transfer function is simply 10. And if there is a tolerance of 10% over the G, in that case, you are getting the tolerance of 1% over the transfer function. Yes. So you can say the net worth of the transfer function is equals to of 10%, 10 plus minus 1%. So nobody should have any doubt as such. So tell me what's going to be the best most answer. Obviously, the best most answer has to be A. Best most answer has to be A. No. If I would take another scenario. Sir, tell me what is that? See, because of the change in G, I don't want much change over the T. What would be your design factor? See, in that case, what I would do, I would be keeping the value of GH much higher. Keep in mind, if the GH has been kept much higher, what will happen? This factor would be so smaller. If this factor is so smaller, the factor which is going to be multiplied with a very smaller factor would become a very, very smaller factor. What does it mean of it? Although there is a huge change in G, but the impact of the change in G could not reach to T. Obviously, if you want to reduce the percentage change in T, although the change in G is still 10%, you can raise the value of open loop transfer function, which we have already communicated in the last class. So probably nobody should have any doubt. If you guys are having any sort of doubt, you can put it over the live chat. Tell me, you can put it over the live chat. Still, let me recall. See, this was G, this was a percentage in G. What does that mean by the percentage in G? That's the dou G divided by G into of 100%. It's the attenuator, it is in place of H, so here's the value of H. G, H, dou G divided by G into of 100%. We wanted to know the T. The T would have the two part, the absolute part and the changing part, which is nothing but the T plus minus dou T divided by T into 100%. So obviously Rajesh Kumar have given the clear sir, but anyways I want more number of input and be focused over the each and individual problem, because the question which I am going to take in the classes, keep in mind those all questions are going to be superbly designed questions, because each question would have its own gravity and each question is going to teach you so many number of concepts. Yes, no issue. So let me go ahead and let me go into the next question. And the second question is also dedicated from the concept of sensitivity, and although it might be looking a theoretical based problem, but once you will go into the detailed study of this problem, you will get to know it has got good amount of numerical concepts. Yes, try to understand what the problem indicates. The problem have come in gate instrumentation year of 2007. The problem was designed by IIT Kanpur. And keep in mind, again you can put the 3 star over this question. Why so, sir? again this question is going to teach you so many number of things. So let me read the problem word by word, and once the concept of the problem is done, we will go into the few detailed analysis. Sir, this is for the EC or only EE? My dear friends, the last question which we saw have come in electrical. This question which we are watching now, it have come in instrumentation. Two problem have already come from electronics, so I can say it is important for all of three branches. Need not to worry about it. See. If any of the topic which is specific to the electrical, electronics or instrumentation, already I have taken to the very last of my syllabus, and even I would be clearly specifying this and this branch need not to appear on that topic. So whatever I teach, at least in control system, by default it is for electrical, electronics and instrumentation. You need not to take any pain out of this. Yes. Anyways, the guys, by watching this problem, would you able to figure out what would be the best most answer as far as this problem is concerned? Yes, tell me. A feedback control system while with high gain K is shown in figure below. Yes, we have got a block diagram of a system. Yes, the forward gain which has been offered to the system is nothing but the K times of GS. Yes, this is what my output. The output has been fed using the HS, and again it's a negative feedback, and definitely it is getting subtracted from your reference signal. Yes. So now then the closed loop transfer function is, there are 4 different options has been attached along with this problem. May I know what are they? See, first, sensitive to the perturbation. See, keep in mind, many of the times I have seen the perturbation, it's an English word. Probably the student who are not very well acquainted with this word may be leaving this problem. You need not to worry about it, my dear friends. Keep in mind, whenever I come across a perturbation, basically it indicates changes. So let me read the each and individual options, and you will find the problem much comfortable. So try to understand what the problem states. Sensitive to change in GS and HS, sensitive to change in GS but not to perturbation change in HS, sensitive to change in HS but not to change in GS, and similarly insensitive to perturbation in GS, perturbation in change in GS and HS. See, probably tell me how would be the best most answer C. How would be the best most answer C? I want the input from each one of you. Try to understand this one. See, variation, perturbation, what they are looking for? They are looking for the sensitivity. See, try to understand in this way. Then the closed loop transfer function. My focus is on transfer function. How effectively it is getting changed because of change in GS-HS, GS-HS, HS-GS, GS-HS. Put together, they are looking for its sensitivity in terms of GS or HS. That means we wanted to know for this particular system, the sensitivity of the transfer function is how dominant because of the change in GS as well as HS. If it is much dominant for the GS and it is least dominant for HS, I would say it would be perturbated towards the GS, and whereas it is not perturbated towards HS. Agreed? And if it is sensitive for both of them, so I would be calling it is perturbated for the GS as well as HS, so on and so forth. Anyways, as far as the problem is concerned, my basic focus is around sensitivity. Yes. Nobody should have any doubt as such. So let me do one thing. Let me rub this out. So it's gone. So let me take few situations. So let me see, sir, what are they? So I don't had only to calculate the sensitivity of the transfer function because of change in G. Yes. Because of change in G, even I need to calculate the sensitivity of the transfer function because of change in H. Yes, change in H. And I would say one more thing, even they may ask the sensitivity of the transfer function because of change in K. See, sensitivity is a mathematical fundamental, which has been used in case of control system. There could be change in G, there could be change in H, there could be change in K, and if you have a complex system, even they can have the change in different blocks. So you need not to stick to the formula and you need not to by heart anything, just go with the flow. What is the flow says? Sir, stick to the basic concepts. Yes. Agreed what I am saying? So here is going to be ST of G. What does it mean of it? That's the sensitivity of the transfer function because of change in G. What about the STH? The sensitivity of the transfer function because of H. So tell me what would be the ST of G? The student who have gone through my last class where I have just started the concept of sensitivity, probably they would be able to judge what would be the worth of STG. What would be the worth of STG? See, initially we had a closed loop system where I didn't have K. I had only and only GS as well as HS. May I know what was the perturbation? The sensitivity can also be called as the perturbation of T with respect to the change in G in case of closed loop system. It was simply equals to 1 divided by of 1 plus GH, but here it would come KGH. If you want, you can derive somewhere. If you want, I can derive it also. Tell me how would be the derivation? The sensitivity of A over B is being written as dou A divided by of A into 100%, dou B divided by of B into 100%. End of the day, it becomes B divided by of A, dou A divided by of dou B into 100%. 100% goes off. Yes. And here it is nothing but ST of G. ST of G. Yes. Yes, sir. Instead the B there is a G, instead the A there is a T. Agreed? Obviously, sir. So here comes G. G would remain as it is. Tell me what would be T. The T. Instead the G, now you can do one thing. The G and K can be taken together for just calculation of the transfer function. So here the KG, which would become a forward path gain, and here the feedback is nothing but the H. So here goes KG divided by of 1 plus KGH. Nobody should have any doubt as such. Agreed what I am saying? Nobody should have doubt as such. Now let me go ahead with the next one. Tell me what it is, sir. It's going to be dou of dou G, and here goes the differentiation of the transfer function with respect to the B. So tell me, sir, what it's going to be? It's going to be, sir, KG divided by of 1 plus of KGH. 1 plus of KGH. Yes. The G and G goes off. G and G goes off. The K and K goes off, and here goes STG. STG, the 1 plus of KGH, KGH, even the G and G is gone, K and K is gone. So here goes 1 plus of KGH whole square. Yes, here goes 1 plus of KGH, and you had to calculate this complete term out. Tell me what's going to be the best most answer. The student who are live with me, definitely you guys can give me the exact answer at least for this particular problem. See. End of the day, what you have to do. It has been clearly written, the gain K is very high. That means once you will calculate the perturbation of T because of G, end of the day, you also have to feed limit K tends to infinity. Why? Because the gain K is tending towards infinity. Here also you have to do the same. So here goes limit K tends to infinity. So end of the day, what's the result you are getting? It would be sensitive towards the perturbation because of H, whereas it would be insensitive towards the perturbation of GS. Why? Once you will be feeding limit K tends to infinity, you can see very well the K have come towards the denominator side, and once you will feed K is infinity, the worth would become 0. What does that mean of it? That means although the G's keep changing, the percentage change in G has been noticed, but that could not be reflected towards T, and that is why the factor which has come over here, it's 0. That is what I am saying. Now you can calculate by yourself. As such, there is no rocket science from here onwards. Agreed? No issue as such. Now this problem goes to you guys. Tell me how would you calculate this? So the calculation would be, see, the same fundamental. The B would come over here. The B is nothing but H. Here would come KG divided by of 1 plus of KGH. Here goes dou divided by of dou H. Here goes KG divided by of 1 plus KGH. And here whatever the factor comes out, you had to feed K tends to infinity, and you would be getting a good amount of value over here, which is constant. Probably 1 or something would be coming out of this. Yes. So I would recommend to each one of you, at least go through these 2 problems related to the sensitivity, because they are going to teach a very good concepts from the concept of the sensitivity. Like here it became 0. What does it mean of it? If you want, I can go one step ahead. STG is nothing but the percentage change in T, which is percentage change in T because of percentage change in G. How much it is? It is nothing but STG for very high value of K. How much we got it? We got it simply equals to 0. That means although there is a major change in dou g divided by g into 100%, maybe 20% or 30% g had got increased, but once this factor gets multiplied with 0, what will happen? The change in t is simply null. Change in simply equals to null. Yes? Agreed? So may I know till this point each and everything is clear to all of us? If it is clear, just write clear, so at least I'll get to know the things are properly communicated from my side. Tell me. If it is clear, just tell me clear. Just tell me clear. Is that part clear? So anyways, let me move into the next topic, and here I would be discussing about the concept of ROUTH. If it is clear, I want the feedback as clear. Suresh, thank you dear. Okay, then move it to the next topic, and here I would be discussing about ROUTH. Here we are going to discuss about the ROUTH. Yes. Here we are going to discuss about the ROUTH, and one thing is quite Ambika, thank you dear, once again, nice to see you, Ambika Misra. Yes, so, let me discuss about the ROUTH. So before going into the detailed study of the ROUTH, let me discuss why the ROUTH itself is important, and keep in mind the one question is supposed to come from this topic for sure. Either you are from electrical, electronics or instrumentation. Sure sort one question is supposed to come. Sure sort one question is supposed to come. Agreed? So may I know few of the important point I can write before going into the detailed study. Before going into the detailed study. Yes. Tell me sir, what are them? What are those? See, may I know why the ROUTH is being used? The ROUTH is being used for analyzing the system's stability, whether the system is a stable system or not, obviously. Sir, but for making or for processing with the help of ROUTH, we should have input. With the help of which input I should proceed further? Tell me what would be the input. If you guys would be able to recall probably 3 to 4 days back when I was discussing about the different component of the transfer function, we got to know the transfer function would have the 3 different components, which starts from zeros, goes to poles, and similarly DC gain. So may I know which factor was the responsible factor for the stability or the pure stability of the system? They were nothing but the roots of the denominator or the locations of the pole. So if you guys would be able to recall, as far as the transfer function, which used to be the function of S, is concerned, you will have the 3 factors. You will have the numerator's polynomial and you will have the denominator's polynomial. If you take the reference of closed loop system, what used to be the closed loop system? It used to be the closed loop system's transfer function used to be g divided by 1 plus gh. So if we compare both of them, at least we will get to know about it. The denominator's polynomial is same as 1 plus gh in case of standard negative feedback system. Negative feedback system. And as we have saw earlier, the absolute stability has to only do with the closed loop poles. That means it has to only do with ds is equals to 0 or 1 plus gh is equals to 0. So let me do one thing. Let me go into the next important point. The absolute stability. Has to only do with closed loop poles. And how you would get closed loop poles? Getting the closed loop poles are very easy. Just you have to form an algebraic equation, which is denominators, which is a function of s compared with 0, or 1 plus gshs is equals to 0. So whatever the root we get, either from ds is equals to 0 or from 1 plus gh is equals to 0, those all roots are the poles of the given system. If all of the roots or all of the poles are towards the left hand side of the S plane, keep in mind the system would remain a stable system. So the absolute stability has to do only with the roots of the ds is equals to 0 or 1 plus gh is equals to 0. 1 plus gh is equals to 0. So in future you can say one thing. If you talk about the inputs to the inputs to the ROUTH-HURWITZ. So it would always be 1 plus GSHS is equals to 0. Rather writing it GSHS, I am simply writing it GH is equals to 0, but nobody should have any confusion. It is simply 1 plus GSHS is equals to 0. And may I know what it would be called in future? Whenever I refer the word characteristic equation, by default I am referring 1 plus GH is equals to 0. 1 plus GH is equals to 0, which is a characteristic equation, and keep in mind the characteristic equation would become the input to the ROUTH-HURWITZ in future. Anyways, rather writing it ROUTH-HURWITZ again and again, I would just be referring it by RH. So as far as the ROUTH-HURWITZ table concerned, the ROUTH-HURWITZ stability is concerned, what would be the input to the ROUTH-HURWITZ is simply going to be 1 plus GSHS is equals to 0, which would be called as the characteristic equation. Many of the students also used to have doubts, sir, why we start with the characteristic equation. See, the characteristic equation, or the roots of the characteristic equations are the locations of the pole, and the locations of the poles are going to decide your absolute stability. That is why the input to the ROUTH-HURWITZ is always be 1 plus GSHS is equals to 0. 1 plus GSH is equals to 0. So till this point nobody should have any doubt. Yes. The next point goes. So now one doubt comes in the mind. Sir, if we have algebraic equation like s square plus 2s plus 3 is equals to 0, maybe s to the power of 3 plus 3s square plus 2s plus 9 is equals to 0. So just by watching the locations of the poles, I would be able to understand whether the system is a stable system or unstable system. So why we use a new concept called the concept of ROUTH-HURWITZ? Try to understand in this way. If the order of the system increases, like the highest degree of S, let's take it is 2 or 3, till 3 it is manageable. If the order of the system increases, what will happen? The higher derivative system would be present into your differential equation, and once you will convert into the terms of transfer function, you would be having a higher degree of S. Let's take, if you have a system which has a characteristic equation, maybe s to the power of 5 plus 4 times of s to the power of 4 plus of 3 times of s to the power of 3 plus 2 times of s square plus 9 times of s plus 10 is equals to 0. Now I would ask from each one of you, would you be able to calculate the exact locations of the pole? No. Probably till the degree of 2 or 3 you would be able to get the exact locations of the pole, but once you go into the higher degrees you would not be much comfortable to get the exact locations of the pole. Yes, you would not be able to get the exact locations of the pole. Till this point nobody should have any doubt as such. Yes. One more thing, I would like to ask from each one of you whether you really interested in calculating the exact locations of the pole. I would repeat once again, probably this is the point where most of the student stuck a lot. What I am saying, whether you are really interested in finding the exact locations of the pole or not. If you find yes, write it yes, and if you find no, write it no. I would repeat the problem once again, whether you are interested in finding the exact locations of the pole for finding the stability of the system. The answer should be either yes or no. I am watching over the board, so at least I will get to know how much you guys are going to connect with me. No sir. The first answer have come, no sir. What else? Anybody more? Anyways, go ahead. No, we are not interested in finding the exact locations of the pole. No. Why? See, probably 3 to 4 days when I was talking, I said if all of the poles or all of the closed loop poles are towards the left hand side of the S plane, or I can say there is no pole towards the right hand side of S plane, the system would be a stable system. I don't even bother about where the system which has been towards the left hand side of the S plane, they have been over the real axis, they have been over the imaginary axis, they have this and that. No, I just confine myself whether any of the pole have gone towards the right hand side or not. If the pole has not gone towards the right hand side, the system is a stable system. Agreed what I am saying? This is the point on which the complete concept of the ROUTH-HURWITZ is based on. See, if you have third order system, let's take the two poles are in a form of complex conjugate taking the negative real axis, and similarly now you can take the another scenario, maybe all of three are having the negative real part and having complex value is equals to 0, but both of them are stable system because none of the pole have gone into the right hand side. So what I am saying, I am not exactly interested where the poles are lying. Maybe here it could be minus 1 plus j, here could be minus 1 minus j, here it could be maybe 3 minus 3. No, we are not interested in finding the exact locations of pole. Then you will say, sir, then we are interested for what? We are interested whether any of the pole have gone towards the right hand side of the S plane or not. If any of the pole goes towards the right hand side of the S plane, you have seen in the very earlier classes, it would lead a factor of e to the power of plus t, and e to the power of plus t would produce an unbounded signal towards output side, and once it produces unbounded signal towards the output side, the system is an unstable system. System is an unstable system. That means the same concept would be exploited by the ROUTH-HURWITZ. ROUTH-HURWITZ does not calculate the exact locations of the pole. It just only indicates one thing: how many poles are there towards the right hand side. How many poles are there? How many poles are there? Poles are there in right hand side of S plane. Such a smart person he was. See, that is what I am saying. No, here I am not worrying whether the structure is this or whether the structure is this, because both of them are a stable system. Even the ROUTH-HURWITZ have used the same fundamental. Rather locating the individual roots, he has just given a fundamental where you would be able to notice how many number of poles are there towards right hand side. If there is no pole towards the right hand side, bing on, you are safe. Yes, agreed till this point? Agreed till this point? So nobody should have any doubt as such. Nobody should have any doubt as such. Agreed? So now the next thing comes in mind. Sir, tell me then what would be the procedure? Without locating the exact locations of the pole, how would we able to judge that the number of poles towards the right hand side of the S plane? And anyways, that is nothing but the ROUTH-HURWITZ criterion, ROUTH-HURWITZ table. So let me straight away jump it to the ROUTH-HURWITZ table. So let me go into the next page. And here I would be discussing about the ROUTH-HURWITZ table. ROUTH-HURWITZ table. So ROUTH-HURWITZ table. Agree? So before going to draw a ROUTH-HURWITZ table, one thing should be clear to all of us. The input of the ROUTH-HURWITZ table would always be a characteristic equation. The first thing which would be given to you is nothing but the characteristic equation. And may I know what would be the characteristic equation? 1 plus GSHS is equals to 0. By default, it's gonna be a algebraic equation. Let's take, for just to take an understanding, I have been given or I have been allotted with a characteristic equation which is having degree of 5. Here goes a5 s to the power 5 plus a4 s to the power 4, a3 s to the power of 3. Here goes a2 s square, and then here comes a1 s, and here goes a0. May I know what it is? So in future, whenever you are going to deal with the ROUTH-HURWITZ, definitely in either of the ways you had to come across the characteristic equation, and the characteristic equation is going to be algebraic equation. Yes, it's going to be algebraic equation. And now you would be interested in finding whether the given characteristic equation is a characteristic equation of a stable system or the unstable system. Anyways, one more important point you can write over here. One more important point you can write over here, here. May I know what it's a? It does not locate the exact location. And here it talks about only and only one type of stability, and that is nothing but the absolute stability. It just talks about the absolute stability. What does it mean of it? It would just be communicating whether the system is a stable or unstable system. It would not go into the detailed study of the stability of the system. How stable a system is. No, it's not going to discuss about it. Yes, till this point, everybody should have a crisp and clear understanding. Yes. Anyways, go back to the slide. So the input to the characteristic equation or the input to the ROUTH-HURWITZ is nothing but the characteristic equation. So far, nobody should have any doubt as such. Now, it's a turn to go ahead go ahead for fabrication of ROUTH-HURWITZ table. ROUTH-HURWITZ table. See, what would be the structure of the ROUTH-HURWITZ table? Each and everybody should have clear-cut views on it. See, the highest degree of polynomial which we had in my characteristic equation is 5, so it would start from 5. It would go to the 4, 3, 2, 1 and it would land up at to the s to the power of 0. If the highest degree of the characteristic equation is, let's take 6, it will start from 6 and would go to 0. And if the highest degree of the characteristic equation is n, then it would start from s to the power of n and would land to the s to the power of 0. Or in totality, I can say the number of rows which you would have, here it is 5, the highest degree, the number of rows would be 6. If the number of degree or the degree of this characteristic equation is n, the number of rows would be n plus 1. N plus 1. Agreed what I am saying? So let me start with at least this problem. It starts from s to the power of 5, goes to the s to the power of 4, here goes s to the power of 3, s to the power of 2, s to the power of 1, s to the power of 0. Yes. How many number of rows we had? The 6th number of rows we had. What's going to be the degree of this algebraic equation? The degree of this algebraic equation is 5. So that is what I am saying here. The number of rows which you would have in your ROUTH-HURWITZ table would be just plus 1 by the degree of the algebraic equation. Degree of the algebraic equation. Nobody should have any doubt as such. Agreed what I am saying? See what is happening over here. Whenever you come across the characteristic equation, at least 2 things you have to ensure. What are they, sir? Tell me. First, you had to arrange the algebraic equation into the form of decreasing degrees of polynomial, DDP. Yes, like the first one was 5, then 4, then 3, then 2, then 1, then 0. This should not be shuffled like, yes, that's the first thing. Secondly, there should not be any missing coefficient. No, there should not be any missing coefficient. Because I have seen, meanwhile, the problem deliberately is getting designed. What they would have A5 non-zero, A4 non-zero, A3 non-zero, A2 0, A1 non-zero, A0 non-zero. So definitely there would not be any presence of A2 s square, but still you had to force to be A2 s square over this, and there the A2 would become 0, where the value of A2 would be 0. So at least whenever you come across the characteristic equation, you should have the clarity. There should not be any missing term, and at the same time the polynomial must be in decreasing order. Yes. Then let me start feeding the coefficients. This would be coefficient. What would be they? The A5 till A0, they would be the real coefficient. They would be the real coefficients. Yes. Till this point nobody should have any doubt as such. See how we start feeding the data. The datas are fed into the alternating fashion. May I know, sir, what it is? So you will start from a to the power 5. Here a to the power of 5 would come. Here a4 would come. Here a3 would come. Here a2 would come. Here a1 would come. Here a0 would come. A0 would come. Yes. Till this point, nobody should have any doubt as such. I would repeat once again, because this is the point where the student do mistakes. What I am saying, the data has to be fed in the alternating fashion. You have to start from the A5 have come over here, the A4 would come into the second row, then A3 would again at first row, A2 at second, A1 at first, and A0 at second. Till this point, nobody should have any doubt as such. So, as far as the characteristic equation is concerned, the starting 2 rows of the ROUTH-HURWITZ would come from the characteristic equation itself, but the remaining rows has to come by little bit process. Let me see which process has to get followed. Yes. So the process are more or less related to the determinant. So tell me, sir, how we get the determinant? If we get the determinant used to be A5 into A2 minus of A4 into of A3. No, it should not be the case. Here we used to take the reverse determinant. Why we take reverse determinant? If you want, I can show you the derivation of the ROUTH-HURWITZ, from where the ROUTH-HURWITZ have come to the conclusion that a table itself would be able to indicate how many number of closed loop poles are there towards right hand side. But this is not the agenda of my smashing class, or not even the agenda of GATE. Nobody is going to ask from where this complete outcome have been derived. Yes. Till this point, nobody should have any doubt as such. Yes. So what I'll do, I'll go into the next 4 number of rows and I need to fetch the data by taking few number of processes. Tell me, how would you do that? See. Try to understand it this way. Let's take this data is x1. Rather calculating x1 here itself, because I would be having a lack of space, so I would be calculating x1 somewhere else. Tell me, how would be the x1? Rather taking the determinant, I would be taking the reverse determinant. So here goes a4 gets multiplied with a3, a4 gets multiplied with a3, minus of a5 gets multiplied with a2, and at denominator a4 comes. A4 comes. Nobody should have any doubt as such, at least for the calculation of x1. Yes. Now let me take the next coefficient which would come into this table, x2. Tell me how the x2 would go forward. See. Now nobody should do the multiplication like this. Here also the student do mistakes. Always you had to fix the first column and the multiplication would take place between the second column and the third column. Like in first data, the multiplication was taken place between the first as well as second column, but in second data, the multiplication would take place between the first and third column. Nobody should have any doubt as such. Yes, while calculation of x1, there would be a mingling between this, but once you'll be calculating x2, there would be a mingling between this. Agreed this point? So tell me what's going to be the x2 over here, and I have seen many of us would used to have ambiguity. So, no, like this, you had to start from a4, go to a1. So here goes a1, a4, yes, and here goes a0, a5, yes sir, no issue, and still the a4 would come at denominator, yes sir, perfect, yes. So here the x1 is known to me, x2 is known to me, yes, and if I would take x3, tell me what would be the worth of x3, see, again if there is nothing, you can just assume as a 0 and 0, 0 into a4 that's a 0, 0 into a5 that's a 0, divided by a4 that would be 0 again. So if you want you can write x3 or you can simply leave this out, agreed. If you want simply I can write this as 0. So at least you will have a clear cut fundamental how the process is being proceeds. So now it's a turn to get the value of x3 over here, x3. Can you tell me how do we calculate the value of x3 now? Now I think each one would have a little bit idea. The x1 would get multiplied with the e2, x2 would get multiplied with the a4, and similarly x1 would come at denominator. So let me calculate that. So here goes my x3. The x3 is going to be simply equals to of x1 into a2, x1 into a2, and here goes x2 into a4, x2 into a4, and here comes x1. Here comes x1. Agreed? And similarly, if we wanted to calculate the x2, tell me what would be the worth of it. See. x1 gets multiplied with the a0, that's going to be x1 a0 minus of 0 divided by of x1, simply it's going to be a0. Simply it's going to be a0. Did you notice or not? But this a0 is jumping. Yes. Initially the a0 was here and now the a0 have come here. Now it's turn to calculate. Maybe you can write this as x4 and here x5, here it's x6. Obviously, let me try that. So tell me what's going to be the x4 over here. The x4 would be very easy to calculate. Tell me sir what it is. The x4 would be equals to of x3 into x2, minus of a0 into x1, x1 divided by of x3. So nobody should have any doubt as such. Yes. And if we talk about the x5, simply it's 0. How sir? This is 0 data, the x3 would get multiplied with 0, that will become 0, x1 would get multiplied with 0, would become 0, the 0 minus 0 divided by x3 simply becomes 0. So why don't we write over here simply equals to 0. Yes, each one of us would agree at least on this all complete process. Although many of us would be knowing it, that is why I have seen and I am watching that over the live chat most of us are silent, but still you should have the clear cut idea as such. Yes sir. May I know what would be the x5 sir? No chance sir, it would be 0. And if we talk about the x6, if we type or talk about the x6, tell me what's going to be the x6. See. x4 is going to multiply with the a0. The x3 is going to multiply with 0. So here is going to be x4 into of a0 minus of 0 divided by x4. Keep in your mind, end of the day, the last coefficient which comes along the S0 would always be your A0. Yes, would always be your U0. Yes, that means if you are not making any mistakes in between, if you are not making any mistake in between, there is no other way this coefficient has to come down to the last row. Because I have seen many of these students do so many number of mistakes and they land up to a very different scenario. Yes, they get something here and there, but anyways, lump sum at last you can check whether the result which have come into the last row favors you or not. Yes sir, it favors me. It favors me. The last data would always be A0. One of the very interesting thing which I wanted to notice over here, tell me what it is, Anyways, so far each and everything was looking so smooth, but only one change let me introduce, and that one change would smash the problem completely. Tell me what it is. See, when we wanted to calculate the value of x1, the A4 came at denominator. We wanted to calculate the x2, A4 came at denominator. We wanted to calculate x3, x1 came at denominator. We wanted to calculate x4, the x3 came into the denominator. What does that mean of it? You had to be very cautious about it. That means A4, then A4, x1, x3, they are very crucial polynomials. They are very crucial coefficients. Why sir? Because they come at denominator. Yes, they come at denominator. If any of the data becomes 0, if any of the data becomes 0, you would not be able to calculate either of the term in terms of x1, x2 and x3 and x4, and end of the day, that's it. Could you understand what I am saying? The x1, x2, x3 and x4, they have been the part of the denominator while calculating the rest of the term, and if A4, x1 or x3 became 0, that's it. You would not be able to calculate the x1, x2, x3 and x4. So sir, what should we do now? If this becomes 0, there are two different issues you will be getting. You would not be able to calculate forward. Not only that, even I will see after some time that I used to be focused over the sign of the first column. The 0 cannot be classified as a positive term or the negative term. There also I would have a big ambiguity. That means I will not be allowed to have 0 in the first column. Why? There are two different reasons. First, if 0 comes in first column, you would not be able to calculate the rest of the coefficient. Secondly, the sign of the 0 itself is not known, because in future the number of poles towards right hand side of the S plane is just being calculated by the number of sign changes in the first column of the ROUTH-HURWITZ. The 0 cannot be classified under the plus as well as minus. Yes. So tell me, how will we do with this situation? In that case, I am just splitting the ROUTH-HURWITZ into the two parts. First is a normal case. May I know, sir, what does it mean by the normal case? Normal case, that means neither the A4 nor the x1 nor the x3 nor the x4 is 0. That means you would be able to calculate the remaining terms easily. Could you understand what I am saying? Could you understand? No. Again I am repeating, could you understand what I am saying over here? So here is nothing but if any of the coefficient becomes 0, you would be standing at a certain condition. Neither you would be able to judge the sign of this coefficient, nor you would be able to calculate the remaining coefficient. Sir, we will take a constant with limit tends to 0. We'll see, Ambika, it's not that straight. So many concepts are getting involved. See, if you want, I can give you from where this complete condition have been arrived by giving a derivation. But this is not the part of GATE, not the part of my crash course. Agreed till this point? And now I would take spatial conditions. Yes. Spatial conditions, I would be bifurcating into the two parts. Yes, sir. Spatial conditions, I would be bifurcating into the two parts. So tell me, what are those? The first part would be spatial condition 1. And second one would be spatial condition 2. Yes. What does it mean by the spatial condition? The first data is 0 in non-zero row. That means if 4 number of datas are there in a certain row, and if the spatial condition 1 have arrived, the first data would be 0, and if the first data is 0, definitely you got trapped. but still there would be some data which is non-zero, or I can say it is in non-zero rows. That would be your first condition. But anyways, you need not worry about the first condition, because I would take few number of examples, and with the help of examples I would show you how the first condition would arrive, or the first special condition would arrive, and similarly how the second condition would arise. And the second one would be, you have the first column's data is 0 in a complete 0 row, yes, in a null row or 0 rows, yes. Till this point nobody should have any doubt as such. Agreed? So when the special condition arrives, if any of the data over the first column becomes 0. Agreed? Obviously everybody would agree on that. Now even the first data over the first column becomes 0, you may come across the two different conditions. What are those, sir? Special condition 1, when only one data is 0, or first data is 0 in a non-zero rows. That means in a complete row at least one data is non-zero. Yes. Similarly, the second one, the complete data is meshes. Anyways, we will try to understand how do we analyze this data. Let me go into the next. Yes. So write down statement of ROUTH-HURWITZ. Number of sign changes in first column of ROUTH-HURWITZ table is equals to number of poles at RHS on S plane. I would repeat once again. The statement indicates the number of sign changes in first column is same as the number of poles at RHS on S plane. So let me go back. Let me copy this out. Let's see what are the data are getting copied. Let me move it. Here goes the data. Just a minute. Anyways, let me go back. Here I wanted to say how many data you had. 1, 2, 3, 4, 5, 6. 6 data you have. So how many ways those data could be? Because I am just focusing over the first data. You can have the situation all of the 6 data are positive. 1, 2, 3, 4, 5, 6. All of the 6 data are positive. Now tell me how many number of sign changes you have. Yes. No sign changes we have. Yes. If you have no sign change, tell me the number of poles towards right hand side. Number of poles towards RHS. As per the statement, the number of sign changes are precisely same as the number of poles towards right hand side of the S plane. And as far as this problem is concerned, the first, second, third, fourth, fifth, sixth, all of the 6 coefficients are found to be positive. Put together, there is no sign change. If there is no sign change, keep in mind the number of poles towards right hand side would be simply equals to 0. Yes, agreed what I am saying? Now let me take few more details within this itself. As far as the ROUTH-HURWITZ is stable, ROUTH-HURWITZ statement is concerned, ROUTH-HURWITZ does not talks about the number of poles towards the left hand side, neither it talks about the number of poles over the imaginary axis. See, until and unless you do not make a special case 2, may I know whether it is the case of special 2 or not? No, because the first term, all of the terms were non-zero and even the positive. The special case 2 would arrive only and only if the first element is 0 in a complete 0 row. If the special case 2 is not arrive, keep in mind there is no pole over the j omega axis. I would repeat once again. What I am saying, until and unless the special case 2 has not been arrived, there would not be the pair of poles or the poles over the j omega axis. There would not be any poles over the j omega axis. Till this point, each and everything must be clear to all of us. Yes. So may I know how many poles are towards left hand side? How many poles are towards the left hand side? How many number of rows we had? 1, 2, 3, 4, 5, 6. That means it would have been started from s to the power of 5, went till s to the power of 0. So how many number of total poles we have? How many total number of poles we have? Tell me how many total number of poles we have? If the highest degree of the algebraic equation is 5, so the number of poles would be 5. Minus of number of poles towards the right hand side, how would we get that? We can easily get from the number of sign changes, which is nothing but 0, minus of number of poles towards the j omega axis. And as far as this problem is concerned, it has not gone into the special category of 2's problem. By default, there would not be any pole over the j omega axis. So the number of poles towards the left hand side is simply 5. And may I know whether the system is a stable system or unstable system? Definitely nobody can deny over it. It's gonna be a stable system. A stable system. Yes, it would be a stable system. So till this point, each one of us would have the clarity. Yes. Now even you can have the situations like, let me take the second scenario over the same problem. The first is negative, second, third, fourth, fifth, sixth. All of the terms are negative. Nobody should have any confusion. We discuss or we calculate the number of sign changes. Minus to minus, no sign change, minus to minus, no sign change. And if you start from s to the power of 5, go till s to the power of 0, there is no sign change as such. So here it goes, no sign change. No sign change, or I can say the poles at RHS is simply equals to 0. Poles at RHS. Repeat, Sasti Gupta, anyways, once you will study the special case 2 from my side, really you are going to enjoy the ROUTH table. So do one thing, until and unless I do not go into the special case 2, you would not be able to appreciate the basic concept of the special case 2, because yes, it contains good amount of concepts. So anyways, 4 to 5 number of problems I am going to take dedicatedly over the special case 2. You need not to worry about it. You need not to worry about it. Yes, and here now again there is no special case. So here at LHS, or you can say at j omega, just a minute, at j omega, what it is at j omega, there is no pole. And here at left hand side, all of the pole would be at left hand side. So let me take two more scenarios. May I know what are they? See here, minus, 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 plus, minus. And let's take the fourth one. Minus, plus, minus, plus, 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 minus, plus, plus, minus. Tell me how many number of sign changes we have in the third system as well as fourth system. How many number of sign changes we have in the third system as well as fourth system. The second is also a stable system. Yes. Tell me how many number of sign changes we have. See, minus to minus, no sign change, minus to minus, no sign change, minus to minus, no sign change, minus to plus one sign change, plus to minus another sign change. The first sign change goes here, the second sign change goes over here. The two sign changes we have. In case of 3, and similarly in case of 4, it's a 1, it's a 2, it's a 3, it's a 4, no, it's not 4, 3, and here it's a 4. So the number of sign changes are 4. So anyways, once we'll take few number of problems, you guys would have clear cut idea how many number of sign changes we have and how we will assess the number of closed loop poles towards right hand side. But one thing is quite sure, the concept, the situation, the behavior of the system which has been taken, at least for the case number 1, 2, 3 and 4, they are the case of normal case where the first term is a non-zero term, and that is why we are able to judge whether they are positive or negative. See, if the first term itself is 0, would you able to say whether the 0 is a positive or negative term? No. In that case, definitely this concept would not be that true. Yes. So till this point, nobody should have any doubt as such. So let me do one thing. Let me take brisk few number of problems. Yes. So let me design problem by myself, and we'll try to judge whether the ROUTH HURWITZ or the concept of ROUTH HURWITZ is working fine or not. So let me take the first problem. Here goes my first problem. Here goes my first problem. Let's take my characteristic equation is. Let's take my characteristic equation is. This is what my characteristic equation is. Anyways, first of all, this problem is not going to come in a gate examination. Why? Because here, the equation itself has been given in terms of factor, and if the equation itself has been given in terms of factor, easily you would be able to locate the exact locations of the pole. Where they have been located at -t and they have been located at -3. -2 as well as -3. Tell me, the system is a stable system or an unstable system? Obviously, all of the poles, how many number of poles? 2 poles, they have been kept towards left hand side of the S-plane. By default, the system would become a stable system. Yes. Anyways, this problem is not going to come in a gate examination, but using this problem, I would at least try to judge the concept of ROUTH-HURWITZ table is working fine or not. Working fine or not. I wanted to ask from each one of you whether this system is a stable system or unstable system. That is going to be my first problem, or the first question which I am asking from you guys. And the second question, the number of sign changes this problem would have. Number of sign changes this problem would have. Tell me. S plus 2 into S plus 3 is equals to 0. First, whether the system is a stable system or not. Once we will convert this problem into the algebraic equation, and after using their coefficient, I would make a ROUTH-HURWITZ table. How many number of sign changes you would have? How many number of sign changes you would have? See, no sign change. Why, sir? Number of sign changes are very same as the number of closed loop poles of the time being poles towards the right hand side of the S-plane, and you can see very well -2 as well as -3 both are kept towards the left hand side of the S-plane. No sign change. So I just wanted to ensure whether the concept of ROUTH-HURWITZ table is working fine or not. See what I am saying. Although ROUTH-HURWITZ have given a statement, if number of sign changes is equals to of number of closed loop poles towards right hand side, I just wanted to check it out whether it's working fine or not. That is why I have taken a simplest problem, and from there at least you could figure out there is no poles towards right hand side. So if the ROUTH-HURWITZ statement is true, there should not be any change in the first column. There should not be any change in the first column. How do we do that? First we'll multiply them. So if we'll multiply them, it would become S square, it would become 5 times of S, it would become 6, S equals to of 0. So what I would do over here, I would start from S square, go with S, and end of S naught. Agreed? How many number of rows you will have? You will have the number of rows one more than the degree of the algebraic equation. And here the degree of the algebraic equation is 2. So simply is going to be 2 plus 1, that's 3. And as I have said, first it has to be arranged in the decreasing order. Obviously it's there, and there should not be any missing term. That means it should not be the case of S square plus 6 is equal to 0. If it is a case of S square plus 6 is equal to 0, deliberately I would feed over here S square plus 0S plus 6 is equals to 0. Agreed? Bang on. Agreed? So here goes 1. Alternatively I feed 5, and here it goes 6. May I know what would be the last data? Here it goes 5, 6 just 30. Minus of 0 divided by 5, and that is nothing but 6. As I have communicated, the last data would always be A naught. Last data would always be A naught. Yes. So now tell me the number of sign changes. Sir, no sign change at all. Here it is plus, here it is plus, here it is plus. So the number of poles at RHS, that's simply equals to 0. Number of poles at RHS, right hand side of the j omega axis, that's simply equals to 0. Now, number of poles at j omega, that is also 0, sir. Why, sir? Why? At j omega, the number of poles are 0. Yes, it is 0. Why? Because this problem is not the case of special case 2, where the complete row became 0. Not only is the case of special case 1, all of the terms were non-zeros. Yes. So if we talk about the number of poles at left hand side, how many number of total poles we had? It's nothing but the degree of this algebraic equation. How many it is? 2 minus of number of poles towards right hand side, that's 0, sir. Number of poles at j omega, sir, that means all of the poles are kept towards left hand side of the j omega axis, and you can see very well, you would be noticing they have been kept at -2 and -3. So I could say, at least from the first problem, the concept, the statement of the ROUTH-HURWITZ is working fine. ROUTH-HURWITZ working fine. I wanted to ask at least I wanted to ask one thing from you guys. The topic in which most of the students find difficulty, you can put it over the live chat. So at least in future, whenever we come across those chapters, we would take in the great detail. So if you guys find yourself a little bit difficult in a certain topic, you can put it over the comment box. So at least I'll have a fair idea. Yes, I would take those topics in the great detail. So till this point, each and everything is clear to all of us. So probably this must be clear to all of us. Agreed? Agreed what I am saying? Even. Let me do one more thing. And I know many of us would have doubt with this problem. I have taken a next problem. As I have said earlier, they would not be giving the problem in the terms of factor, but still I have taken s minus 1 plus j, s minus 1 minus of j is equals to 0. Tell me which case it would make. Would it make special case 1, special case 2? Would it make a normal case? That's different thing story. And number of sign changes, number of Nyquist, no need to worry about it. Nyquist anyways, even I find Nyquist, most of the students find it difficult. So definitely we are going to spend more time over the Nyquist plot. Yes, no issue. Tell me, s minus of 1 plus of j, s minus of 1 minus of j is equals to 0. So anyways, see, both of the poles are kept towards the left hand side of the S plane, taking the reference of j omega axis. What does it mean of it? That means it is a stable system. Whereas many of the students would find this concept difficult. They would say, sir, the poles are kept over the j omega axis. Dear friends, it's not kept over the j omega axis. It has been kept towards the left hand side of the j omega axis. That's a different story together, that it's a form of complex conjugate. Yes, complex conjugate. So nobody should have any doubt as such. So once we multiply them together, here it's a case of a plus of b, a minus of b. Here goes a, just a minute, a square minus of b square, and here goes 0. Yes, let me expand it. Here it becomes s square, and just a minute, s minus 1. Tell me, what's going to be the worth over here? So here it becomes s minus 1, do one thing, sorry, it is plus here, plus, then only it would come towards the left hand side. Here goes s plus 1 whole square, here it goes s square plus of 2s plus of 1 minus j square. The j square is nothing but the minus 1. Minus 1 gets multiplied with the minus, it would become plus. It would become s square of 2s plus of 2 is equals to 0. And you can see very well, once you will make the ROUTH-HURWITZ table for this particular problem, there would not be any sign change. Why? Because both of the poles were kept towards the left hand side of the S plane. Yes. Let me draw that out. Here goes s square, here goes s, and here goes s naught. Yes, here goes 1, 2, 2. A beautiful most problems I am going to take in tomorrow's class. Although I would be covering that complete 90 minutes for the today's session, but still tomorrow I am going to take a very, very well designed problem from the concept of ROUTH-HURWITZ. The student who understand, they know the concept of ROUTH-HURWITZ fully, still they would enjoy with the each and individual problem. So do not forget to watch tomorrow's video. Anyways, come back. Here it goes 1, 2, 2. So here it becomes 0, and here again it's 2 comes over here. So the number of sign change, how many? Plus, there is no sign change as such. The number of poles towards right hand side, is equals to 0. The number of poles towards the j omega is 0. The number of poles towards the left hand side, 2 minus 0 minus of 0, that's simply equals to 2. Yes, till this point nobody should have any doubt. If you guys are having any sort of doubt, you can put it over the live chat. So at least I would be able to know which type of doubt you guys are having. So till this point nobody should have any doubt. But see, as I have communicated earlier, it is algebraic equation of the second degree. And with the help of second degree algebraic equation, you need not to draw this ROUTH-HURWITZ table. Straight away you would be able to get the exact locations of the pole, and by watching the exact locations of the pole, at least you would be figuring it out whether it is a stable system or the unstable system. Yes. So when the ROUTH-HURWITZ table or the concept of the ROUTH-HURWITZ becomes more dominant once you have a heavy system. What does it mean by the heavy system? Once you have good number of poles, maybe 4, 5 or 6. So let me take few number of problems and we'll try to judge whether the system is a stable system or the unstable system. The time response analysis topic. Anyways, the time response analysis topic is a so huge topic, so many concepts has to be taught over the same topic. So what I have planned, at least for time response analysis, I would be taking a chunk amount of the problem and we would try to extract the concept from the each and individual chunk amount of the problem. So RS, you need not to worry about it. Yes. So let me go ahead. Let me go ahead and let me take a design problem. Let me take a design problem. Yes. So this problem goes to you guys, and probably within 40 to 50 seconds, this problem has to get solved from you, each one of you. The problem is sort of this. The characteristic equation is clearly given with a system, and which is nothing but the s to the power of 4 plus 2s cube plus of 3s square plus of s plus of 2 is equals to 0. Yes. Tell me. So we wanted to get the LHS. LHS is equals to 2, no? 2. No pole at right hand side, no pole at j omega. The degree of the algebraic equation is 2. That means the number of poles which this system consists is 2. So 2 minus 0 minus of 0 is still it would be 2. So anyways, come back to this problem. And I want to know the how many number of poles are there towards the left hand side and how many number of poles are there at right hand side. Now you can see how effective your ROUTH-HURWITZ is. How you can say strong your ROUTH-HURWITZ is. Rather going into the search of the each and individual poles which has been occupied by this structure, you can smash this problem out with the help of ROUTH-HURWITZ table. Tell me. So this problem goes to you guys. So I would start see with S4, S3, S2, S and then S0. Yes. So tell me how the data would be fed. First, it has to be arranged in the descending order. Obviously, it's in descending order. That's fine, sir. No issue. There should not be any missing term in it. No, sir. There is no missing term as such. Here goes 1. Here comes 2. Here comes 3. Here comes 1, and here comes 2. Yes. Yes. I want to know how many sign changes this problem carries over the chat box. Tell me how many number of sign changes this problem carries. I want the input from each one of you. Number of sign changes this problem carries. Tell me. Number of sign changes this problem carries. Yes. No issue. I would change this color out. So let me take the brightest color, and that is nothing but yellow. The two sign changes 80 Ra, I have got it. Let me check it out, 80 Ra is correct or not. So what will do, the basic mistake the people do, they will take the multiplication of this minus of this, which is perfectly incorrect. So what is happening over here, the 2 would get multiplied with 3, that's a 6, minus of 1, that's a 5, divided by f2, that's nothing but 5 divided by f2, that is 2.5, and here it goes 2 into 2, that's a 4. Anyways, 2 into 2, need not to recall as 4. See, next time what is happening over here, 2 into 2 minus of 0 divided by f2, simply it would be 2. Yes. If I am not wrong, the 2 gets multiplied with 2, 1 would get multiplied with 0, and again at denominator the 2 had the division. Yes. So here goes like this. Now in next what we had to do, see, 2.5 has to get multiplied with 1, 2 has to get multiplied with 4. So here goes 2.5 minus of 4 divided by 2.5. Probably I have calculated the values of the each and individual data. So probably this value would be fine. Anyways, the data is minus. How much it's coming, sir? Let me check it out. It's nothing but 0.6 with a minus sign. With the minus sign. Yes. Now what about the last term? See, the last term is going to be minus 0.6 into 2 minus of 0 divided by minus of 0.6. The 2 would come over here, and you can see very well there is no excuse, the 2 has to come over here. 2 has to come over here. So if you talk about the number of sign changes, how many number of sign changes you have? First one positive, second one positive, as such no sign change in first and second, second, third no sign change, third to fourth there is one sign change, and fourth to fifth there is one sign change. So the number of sign changes, or you can say the number of poles towards the right hand side is 2. The number of poles towards the j omega axis is 0. Why, sir? So far it was not the case of special case 2. If the special case 2 is not been fabricated, you need not to worry about the poles over the j omega axis. Yes, I did not have the situation where the complete row got vanished. Yes, and here goes the number of poles towards the left hand side. How many number of roots or the poles we had? 4. Out of 4, the 2 were at left hand side, 0 were towards the j omega, the remaining would come towards the left hand side. Although if we talk about the system's stability, the system is already an unstable system. Is an unstable system. Could you understand? Could you understand why it's an unstable system? You can see very well, my dear friend. If any of the closed loop goes towards the right hand side of the S plane taking the reference of j omega axis, the system becomes an unstable system. System becomes an unstable system. Agreed? Agreed? Anyways, let me do one thing. If the time permits, let me take one more problem. See what it is. And now I am taking the case of special case 1. And probably the time would not permit to go into the special case 2. So probably you can focus over the special case 1 alone. And I have seen this is the point where the most of the students do mistakes. So let me see whether I have taken any special case 1's related problem. Yes, I have taken one. And the problem is the characteristic equation is being given to you, and you had to analyze the system's stability. The characteristic equation which has been allocated along with this problem is going to be s to the power of 5 plus of s to the power of 4 plus of 2s cube plus of 2s square plus of 3s plus of 15 is equals to 0. Yes. This is the problem, and this problem has been designed in such a way that it would make a special case 1. What does that mean by the special case 1? You will have a row where the first data of the row is going to be 0, and at least one element within that row would be non-zero, or you can say the first data is 0 in the non-zero row. Yes, agreed what I am saying? So tell me, how would we proceed with this problem? So first row would be dedicated to the 5, then it goes to 4, then goes to 3, then goes to 2, then goes to 1, and those goes to 0. How many number of rows you will have? 1 greater than the number of degree. Degree is 5, so here you will have the 6 number of rows. Yes, we had. So tell me how the data would be fed in. Here it would be 1, here it would be 1, here it would be 2, here it would be 2, here it would be 3, here it would be 5. Obviously, sir. No issue as such. Yes, sir. And once we start smashing this problem out, now the problem has come. The first data have become 0. If the first data have become 0, there are two problems. What? Whether the 0 has to be accepted as positive or negative, that's the first data problem. And secondly, I would not be able to calculate the remaining coefficients over the row s square, s1, s0. Why? Because they require the value of this coefficient. Yes, that's the first thing. Anyways, what about here? Is going to be 1, 3 is 3, minus of 5, that's a minus 2 divided by 1, that's simply equals to minus 2. That's simply equals to minus 2. Sir, 15. What it is? 15. Okay. Yes. Let me check it out once again whether it was 15 or not. Where you have gone, my dear friend? Yes, it was 15. 2, 2, 3, 2, 2, 3 and 15. Yes, it was 15. Yes. So here goes 1, 3 ja 3, minus of 15, that's a minus 12. Minus 12 divided by 1, that's minus 12. I will repeat once again. So here goes 1, 3 ja 3, minus of 15, that's a minus 12 divided by 1, that's again minus 12. So till this point nobody should have any doubt as such. Yes. See. Try to understand in this way. Can I take 2 common out of this row? can I take 2 common out of this row? I wanted to ask from each one of you, can I take a common factor from a complete row or not? Can I take a common factor from the complete row or not? Tell me. If the answer is yes, write yes. If the answer is no, write no. Can I take a common factor and can I remove that common factor? Yes or no? Yes or no? Yes, I can remove the common factors. And the common factor which has been brought out should not be negative. See here, if in case of maybe if instead the -2, if it would have been +2. See, try to understand this. Now what you are saying, so the common factor in between all of the 3 terms is -2. So what it would become? It would become -2, it would become +1, it would become +6. So what will happen? The sign of the first element would get changed. So what I am saying, you can extract any of the constant term. I would repeat once again, you can extract any of the common term out of the given rows, but that common term should always be positive. Now the second thing comes into mind, sir, what's the benefit? Benefit is there, my dear friends. See, if this data is a smaller data because of extraction of a common factor, the calculation for the future would become easier. The calculation for the future would become easier. Yes. So again I would say you can extract any of the common data. You can extract any of the common, you can extract the common data from row, any of the row, but that common data should always be positive, Why? If the negative common data is being extracted, there would be an impact over the sign change, and because of the impact over the sign change, the stability assessment would not be correct. Till this point, nobody should have any doubt as such. So rather writing it -2, you can simply write -1. Nobody should take -2 common, and here you can write -6. Here you can write -6. This process, this concept is true everywhere. If you want why there would not be any impact, if you want, I can calculate forward. Why there is no impact as such? If you want, I can solve it over here. Why there would not be any impact if any common factor has been taken out from the complete row. If you want, I can derive that. Yes. Anyways, now there is a problem. Tell me whether it's a special case 1 or a special case 2. Now nobody should have any doubt it's a case of special case 1. Why? Because the first component was 0, but that row in which the first component was 0 was a non-zero row. Is that part clear? So this thing is quite clear and self-explanatory. So what I would do, I would take this factor as a very small positive quantity. Now the doubt comes in the mind, sir, should it be a positive 0 quantity or negative 0 quantity? See, that solely depends on the factor just above the special case 1. If it is positive, I would assume zeta is a positive quantity. If it is negative, I would assume the zeta as a negative quantity. Whereas the magnitude of the zeta was 0. So now what I am going to do, I am going to take the input from both of them. It says the zeta has to be positive, it says the zeta has to be 0. So in future, the zeta would be taken as 0 plus. Keep in mind, 0 plus and 0 minus makes huge differences. So the sign would come from the coefficient just above the special case 1, and the magnitude would come, obviously the first row have become 0. So here the first component have become 0. So here simply going to be 0. So in future, whenever it is required, I would be keeping zeta tends to 0 plus. What's the benefit? You have got it. See, the remaining calculation became so easy. May I know what's going to be the term over here? It becomes 2 times of zeta. 2 times of zeta minus 1, and minus 1 would become plus 1 divided by of zeta. Agreed? Agreed what I am saying? See, if the common could not be extracted out of this, would I get the same value? Would I get the different value? See, you will get the same value. See, how? This, and here. So you would have got the same value. And similarly, you had to calculate the zeta with the 15. So what it becomes, let me calculate that. Here it becomes 15 times of zeta. 15 times of zeta, and here it becomes plus of 6 divided by zeta. Anyways, already I have calculated few of the outcomes. So let me mark them out. just a minute, 0 to 15, yes. So here the data or the column, the first data which we have got it in the first column is simply equals to, let me write each and everything, it's gonna be 1, 1, then zeta, then here goes 2 zeta plus of 12, 2 zeta plus of 12 divided by zeta, the next was minus 12 minus of 15 zeta square, 15 zeta square divided by of 2 zeta plus of 12, and the last never the least, the data is gonna be 15. What does it mean of it? Is still the same condition is getting arrived, 15. Is it part clear? So anyways, probably within 2 to 3 minutes this video is getting over. We will meet at least in tomorrow's class. Is that part clear? So first look it over here. So the first data is 1, the second data is 1. What is this? Here the zeta is tending towards the 0 plus. So in future, if you will calculate the value of zeta, the worth is 0, the sign is plus. So would it be counted as positive or negative? Obviously positive. Yes. And here also you would be feeding the same value. Tell me what would be the worth of it. See. The 0 into 2 would become 0 plus of 12, and at denominator it is 0 plus. See, constant value divided by 0 makes it infinity, but the polarity would be positive infinity or negative infinity. It would be solely depends on the sign of 0. If the sign is positive, it would be plus infinity. If it is negative, it would be minus infinity. Anyways, we have talked about the plus infinity and minus infinity in case of engineering mathematics. I need not to recall once again this. What about this? Here also zeta tends to 0 plus. Here it goes minus 12. And here if 0 plus is being kept out, here it's gonna be 0, and here it becomes 12. Put together it's a simply minus 12, and here comes 15. So if we list down the data which we had, it's gonna be 1, 1, 0 plus, then plus infinity, then minus 12, then 15. Yes. Again, I would recall the factor is gonna be sigma tends to 0 plus. If you are just writing sigma is equals to 0, there would be a problem. Few of us would write plus infinity and few of us would write minus infinity, which would not be true. So here tell me how many number of sign changes we have. Only 2 sign changes we have. So the number of poles towards right hand side, 2. Number of poles towards the j omega axis, 0. Why is 0? It's not the special case 2. In case of special case 2, the complete row has to get vanished. Yes. And the number of poles towards left hand side can be easily calculated. The number of poles we had, it's a 5 minus 2 minus 0. The 3 poles are towards the left hand side. Agreed? So till this point, nobody should have any doubt as such. Anyways, in tomorrow's class, we would be discussing about the special case 2, probably 2 or 3 number of questions we are going to take from the special case 2, and once that part is over, we would be taking a very well designed, probably 5 to 6 number of problems, and end of the day, you guys are going to be very much comfortable over the ROUTH. A student who find ROUTH very simple as well as very smashing, still you need to watch the tomorrow's videos. We are going to do very good sums. Anyways, we'll meet tomorrow. Thank you very much.